Chapter 7 is the start of trigonometry, but first, in section 7.1, we'll have our formal introduction to the Pythagorean theorem. So the Pythagorean theorem states, in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. So just as a review real quick, remember that the two sides that form the right angle, those are called legs, and the side opposite the right angle is called the hypotenuse. So again, according to the Pythagorean theorem, you would take the legs and square them, add them together, and that is equal to the length of the hypotenuse squared. So let's put that theorem to use in example number 1. Find the length of the hypotenuse of the right triangle. So again, it states that we are finding the hypotenuse, but again, we would know that even if we weren't told that in the problem, because it is the side opposite the right angle. So again, these are the legs. So this would be like your a squared and your b squared, and then this would be c squared. So we're going to take 5 squared, add it to 12 squared, and that is equal to x squared. 5 squared is 25. 12 squared is 144. If I add 25 to 144, I get 169. And the way I get an x by itself when it's squared is by taking the square root. So in the end, I would get x is equal to, the square root of 169 is 13. So the length of the hypotenuse of this right triangle is 13. Here's example number 2. It wants us to find x. This time, x represents a leg length, so we have to plan accordingly when we are writing out our equation for the Pythagorean theorem. So once again, we would do x squared plus 3 squared, and that is equal to the hypotenuse squared, which is 5. Again, always make sure when you're setting these up that you set it equal to the hypotenuse. So you always need to identify what the hypotenuse is, and that is what is your c squared. So let's simplify this. We have x squared plus 9 equals 25. If we subtract 9 from both sides, we would end up with 16. So when I take the square root of both sides, I'd get x is equal to 4. So our other leg length would be 4. And now on to a story problem. Example number 3. Randy made a ramp for his dog to get into his truck. The ramp is 6 feet long and the bed of the truck is 3 feet above the ground. Approximately how far from the back of the truck does the ramp touch the ground? As always, we need to draw a picture. So to start, we have a ramp that is 6 feet long. So from the base of the ramp up to the truck is 6 feet. Then it says the bed of the truck is 3 feet above the ground. So from here, the bed of the truck down is 3 feet. That would be forming a right angle with the ground. So you can see here we have formed a right triangle. You cannot use the Pythagorean theorem unless you have a right triangle. So it's asking for how far from the back of the truck does the ramp touch the ground. So it's asking for the length down here. Again, we have a right triangle, so this is going to be our leg length that we're looking for. So it'd be x squared plus 3 squared equals 6 squared. Again, make sure that you always set your Pythagorean theorem equal to the hypotenuse squared. Simplifying, we have x squared plus 9 equals 36. I would subtract 9 from both sides. So x squared would equal 27. And then I would square root both sides. Since 27 is not a perfect square, I'm just going to do the square root of 27 in my calculator. Since taking the square root of 27 and putting it into simple radical form wouldn't make sense since this is a story problem. You wouldn't answer this as 3 square root of 2 or something like that if somebody actually asked you how long the ramp is. So again, the square root of 27 is about 5.2. So that length at the bottom there is about 5.2 feet. Example number 4 says find the area of the isosceles triangle with side lengths of 20 inches, 20 inches, and 24 inches. As always, let's draw a picture. So there is my isosceles triangle, and it's asking for an area. So if you remember way back when you first learned the area formula for a triangle, it is 1/2 base times height. So in this case, we could use this as the base. However, the height would be from that opposite vertex straight down as a perpendicular line. So notice that we just formed a right triangle. This would bisect this 24 down here. So I would end up with a right triangle with a length of 12 down here, 20 here, and I'm looking for this length right there because that would be the height of the isosceles triangle. So since I have a right triangle, I can use the Pythagorean theorem to solve for that height. So I would end up with x squared plus 12 squared equals 20 squared, because 20 would be my hypotenuse. To simplify, I'd end up with x squared plus 144 equals 400. Subtracting 144 from both sides, I'd end up with x squared equals 256. If I take the square root of both sides, I would get 16. So that means our height is 16 units long. So going back to the original problem, we need to find the area. So the area would be equal to 1/2 times the base, which we said was 24, and the height, which is now 16. This is really simple to do. You could just do half of 24, which is 12, and then 12 times 16 is 192. Since we're finding an area, and area units are always squared, we're going to say square inches for our unit. So the area of this isosceles triangle is 192 square inches. Let's see another example like that. So here's example number 5. Find the area of the triangle. So just like before, in order to find the area, we need to find this height. Knowing that in an isosceles triangle, the height or the altitude actually bisects this base over here, we would know we'd end up with a right triangle with 15 here, and of course 18 over here, and we're looking for that length right there for the height. So again, we'll use the Pythagorean theorem. Since we're looking for a leg length, it'd be x squared plus 15 squared, set it equal to the hypotenuse squared. To simplify, it'd be x squared plus 225 equals 324. Then I would just subtract 225 from both sides, and I'd end up with x squared equals 99. Taking the square root of both sides, I notice that 99 is not a perfect square. So I'm just going to leave it as the square root of 99. I'm not going to even change it to simple radical form, because all I'm going to end up doing is taking this number, the square root of 99, and use it in finding the area of the triangle. I don't want to round this answer because that would throw off the precision of my final answer. So again, I'm just going to leave it as the square root of 99. So back up at the top here, I know that the area formula for finding the area of a triangle is 1/2 base times height. So again, we did all of this work down here because we needed to find the height. So we would again have A equals 1/2, the base was 30, and the height was the square root of 99. So half of 30 is 15, so I'm just going to punch into my calculator 15 times the square root of 99, and I get 149.2. So again, I'm only rounding one time in my answer. I'm not writing down here and then rounding again for my answer because I want to keep my answer as precise as I can. As always, the area is a squared unit, so it's going to be feet squared. So 149.2 square feet is my final answer. Next, we have Pythagorean triples. A Pythagorean triple is a set of 3 positive integers that satisfy the Pythagorean theorem. There are 4 common Pythagorean triples, and then all you have to do is use their multiples in order to identify Pythagorean triples. The first 2 are the most common, 3, 4, 5s and 5, 12, 13s. I don't so much remember these as often as I do the first 2. Be definitely aware of 3, 4, 5s and 5, 12, 13s. Other than that, I would just use the Pythagorean theorem to find a missing side. I would not memorize this table. So let's look at example number 5. Find the length of the hypotenuse of the right triangle. So I see here I have 21 and 12. I notice that 21 is a multiple of 7 and 72 is a multiple of 24. I took 7 times 3 to get 21 and 24 times 3 to get 72. So to find this missing side, I would just take 25 times 3 and assume, using Pythagorean triple, that x equals 75. But again, I would not memorize these and their multiples. I would only be aware of 3, 4, 5s and 5, 12, 13s. Otherwise, you can always just use the Pythagorean theorem to find a missing side. I could have just as easily said 21 squared plus 72 squared is equal to x squared, and then just found that missing side. That's it for this section. Jot down anything you don't understand that we can cover in class, and we'll see you then.